All right, let's get right into it. For years, the big focus in AI has been on what a model learns. But a new breakthrough is giving us this incredible first look into how it learns. We're talking about an actual visible signature, a pattern that shows us the exact aha moment inside the machine. So for the longest time, the motto in AI has basically been go big or go home. To make AI smarter, you just had to make it bigger. But that's created this arms race for absolutely massive, power-hungry models that cost a fortune and are controlled by just a handful of companies. And it's making a lot of people ask, is there a better way to do this? And this really lays out the dilemma we're facing. On the one hand, you've got these giant models that are unbelievably powerful, but they come with these insane costs and are totally centralized. On the other hand, you've got smaller models that are cheap, efficient, and you can run them on your own devices. But they usually hit a wall, They just aren't as capable. It feels like you're forced to choose between raw power and actual accessibility. But what if that's a false choice? What if, instead of just building a bigger, more powerful engine, we could teach the model to be a better driver from the very beginning? This is a whole new way of thinking about training. This idea has a name. It's called meta-learning. And the best way to think about it is like this. You can teach a student to just cram facts for one single history test, and they'll probably do okay. Or you could teach that student how to study. Teach them how to take good notes, how to connect ideas, skills they can then use for any subject. Meta-learning is basically teaching AI those core study skills. So, how on earth do you teach an AI how to learn? Well, researchers came up with this really clever method. They gave it a ton of rapid-fire pop quizzes. They'd show it a few sentences where a key word, like a city, is blanked out, give it a few examples, and then ask it to solve a new one. By doing this thousands of times with different topics, they force the model to stop just memorizing facts and start seeing the underlying patterns it can use to learn new things incredibly fast. The process itself is this cool two-step dance. In what they call the inner loop, the AI tries to solve one of these pop quizzes on a temporary copy of itself, kind of like a mental scratch pad. Then the outer loop kicks in. The main model looks at how the scratchpad version did and asks, okay, what did we learn from that attempt? And based on the answer, it updates its own fundamental knowledge. Over and over, it builds up this kind of learning wisdom. So this all sounds really smart in theory, right? But does this fancy training method actually pay off? Well, the results are pretty staggering, and it all starts with speed. Get this, models trained with meta-learning reach their performance targets up to 1.6 times faster. Now, in an industry where a single training run can cost millions of dollars and take weeks, that is a massive reduction in time, energy, and money. It's a huge deal. But, okay, faster is great, but are they actually smarter? To find out, the researchers tested them on a really critical real-world task called Named Entity Recognition, or NER. This is just the basic ability to read a block of text and identify things like people, places, and companies. It's used absolutely everywhere, from legal contracts to medical reports. And the results were just crystal clear. The meta-trained models weren't just faster, they were way more accurate. We're talking a nearly 15% jump in accuracy for English and a whopping 18% for Swedish. This isn't just a small tweak, it proves the model developed a much more flexible and adaptable understanding of how language actually works. But as cool as all that is, it's not even the most exciting part of this research. The real breakthrough, the thing that has everyone talking, is that for the first time, scientists could actually see the moment the AI learned how to learn. They found its hidden signature. I mean, that's the million-dollar question, isn't it? We can see the inputs, we can see the outputs, but what in the world is going on in the middle? What does this process actually look like from the inside? Turns out it happens in two very distinct phases. In phase one, which they call diversify, the model's internal brain space, its different ways of representing the world, it just fans out. It's exploring all the different possible ways it could organize information to solve these quizzes. It's messy, it's broad. It's basically the brainstorming phase. And then comes phase two, compress. After exploring all those options, the model has its aha moment. Its internal representations suddenly just collapse into this much smaller, more elegant, and highly efficient structure. It's like it found the perfect way to think about the problem, and it locks that knowledge in, compressing it into this powerful, reusable tool. The researchers themselves describe it perfectly with this quote.
This diversify then compress dynamic, that's the visual signature of meta-learning in action. We are literally looking at the shape of the AI discovering a powerful new mental tool. And this chart right here is the smoking gun. That first bar shows the internal aha moment, the instant the model's thinking becomes super efficient. The second bar shows its actual performance on the quizzes. And just look, they're perfectly timed. The very moment that internal structure compresses, the external performance shoots straight up. This is the first time we've been able to draw a direct line from an internal change in an AI to an external leap in its intelligence.
So let's just zoom out for a second. We have a new way to train AI that makes it faster and smarter, and we can actually see the moment it happens. Why is this such a huge deal?
Well, it changes the game in 4 key ways. We get smarter AI, not just bigger AI. We get more accessible AI, because these techniques could let powerful models run on your phone or laptop, not just in some massive data center. We get more interpretable AI. This signature gives us a real window into that black box. And finally, we get more equitable AI. This method was shown to dramatically boost performance on low-resource languages, helping to close the digital divide for billions of people. All of this really opens up a fascinating final question. For the first time, we're not just programmers anymore. We're becoming teachers. And now that we can finally watch our student learn, it really makes you wonder, what are the truly important lessons we should be teaching it next?